Everybody, it's Tyler here at Western New England, checking in with 7407 Wired Boars. Hopefully you've seen this team a whole bunch of times. We've had them on the OA show, a phenomenal team through Open Alliance and showcasing what their progress is. And we're going to be taking a look here in week 4, how their robots doing support. Some cool changes they've been making from their last event, and you just got to look at this robot overall. Very well packaged for it. We'll be going into all those different modifications, a lot of what's gone into for mechanism, and some great programming work as well too. So let's learn more about Wired Boars coming up here on Behind the Bumpers. Support funds content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support. Here, let's start talking about the mechanical aspects of your robot. Watching on OA, you have an awesome intake on it, and you've been making some changes as we start to follow that note journey. So let's run through them and how you came about them.
Yeah, so this year we decided we want an under the bumper intake because we can slam into things. So our intake mostly works in 3 ways. So here's the spare intake that we have. So the first part of the note, the first part that we intake with is basically these front 2 rollers. So the note comes in like this, and then we have this bottom roller right here, and that's also driven. So basically the note can then pitch up and go into our feeder. But the way we design this allows us also to basically dual intake. So we can also feed in a note from this side because we have another under the bumper, like belly pan roller basically right here. So the note can feed in this way as well. And one major modification we made between our first event and now is we added these 2 rollers. So for dual intaking at the first event, sometimes the note could feed behind the shooter. So basically right here into basically where the limelight is. So we added this extra roller so that can't happen. And then we also had issues with the note feeding under the shooter, like down here. It's kind of hard to see. So we added this roller so the note can never basically go horizontal and it has to feed into the shooter.
So looking at this event, have you noticed a significant improvement so far?
Yeah, we've had 0 intaking failures so far, which is a really good improvement. So as a driver and an operator pair, we don't have to basically have any misconfidence in it. We have 100% confidence that when we get a note, we'll actually intake it. It's really helpful.
Can we see how a note does intake on your robot?
Yeah, so first things first, we have this over the bumper roller. Yeah. It comes down at the start of teleop. So our methodology behind this was we want to be able to intake across the entire robot. And so it's less driver precision. So what we have is these idler rollers right here. So that allows us to vector the note into the center. So we can intake a note and it feeds right into our shooter. And then if you disable, we can also take a look at the reverse side intake. So we wanted to have the ability to clean up notes in our wing. So between our basically Hartford and Western New England, we added this second set of rollers. It's kind of hard to see, but they look like this. They're compliant wheels, and that allows us to basically, when we drive over a note from the front side, we get a really good intake, and it saves a lot of time when we're doing cleanup work. So the next thing we're going to talk about is our tent mech. So on our priority list this year, we had our trap really high because we wanted to be able to get that RP, control our own destiny. So the first thing how this works is we have the motor that puts down the the over the bumper roller. But if you want to hold this up, this motor also powers our tent mech. So what this does is when we run the motor the opposite direction, it brings the tent mechanism out. It rests on the bumper roller, and then this hits off on the bottom of the stage. So as we climb, it causes us to tilt at a very specific angle, which creates like a very reliable trap mechanism. But
I was gonna say, I remember you talking about this on OA show as well too quite a while ago. Did that design change at all from back when we talked versus now?
It's basically the same, but what we did is we had to experiment a lot with what angle we're going on the trap. So as you can see, these have been cut down a bit because we're trying to, this event, we're trying to fine tune that angle that we're tipping towards the stage with. So these have been cut down so we can change the angle really easily, which was part of the design.
And trap scoring so far, watched your first match on it, working out great. Is that something match strategy-wise, that's an every match thing for you guys?
If our partners can climb, yes, we try to get that RP 100% of the time. If they can't, we don't go for it usually because we'd rather have that last speaker cycle, especially if it's amplified, because sometimes it's not worth the RP and we can get points anyway.
Very cool. What else do you want to showcase on this?
Yeah, so when we originally tried the trap, we found that our angle, because our shooters at this angle, we basically shoot it horizontally into the trap, but we realized that it wouldn't work because the angle was too perpendicular to the trap. So what we did is we added this trap flap. It's a low friction material that allows us to redirect the note. So as the shooter rotates up, it deploys. And then as we rotate down, and when we're climbing on the trap face, it actually bends downward and causes the note to rotate down into the trap. Yeah, we can show the climb sequence here. So the first thing we do is we raise the elevator to get above the chain, and the tent goes down. So we flap the tent out, and then you need to use the driver controller to put the elevator down. So what happens here is we lower the elevator, and the chain hands off to these stationary hooks. Then we can raise the elevator again in a sequence that allows us to score in the trap. So this would be bent down, and the note would just basically bend around into the trap flap, into the trap.
So cool to see us in person versus when we were talking on show, to have all this come together and all this fruition on this as well. You know, looking through the entire Crescendo season, what are maybe some of your biggest lessons learned that you saw in this game that maybe you didn't experience before?
Yeah, I think at our first event, we really wanted to prioritize, you know, like just getting the cycles in. And I think more and more we've realized that how important the amp is. So at our first event, our amp was pretty meh, but in between the events, we've made a couple changes and our amp has gotten a lot more consistent, just because in terms of raw output in the game, scoring amplified is always worth it. So we've been practicing a lot of 2 in the amp, 1 in the speaker, 2 in the amp, 1 in the speaker. So we've learned that more than cycles, it's important to maximize your amplified period.
Being an Open Alliance team, we talk a lot about your design decisions as you go through the season. What are maybe some key ones that you had to focus on that really were implemented on the robot this year?
Yeah, so early in the season, we did a lot of flywheel testing data, and we published it all in our Open Alliance thread. And what we found was we see a lot of teams doing, you know, the independent sides, but what we wanted to do because of our prototyping data was just decrease the width of one set of the wheels. So this stealth wheel right here is cut down to 1/2 inch. So this provides a bit of spin on the note, which makes it fly a lot straighter. But having these connected together makes our shooting so it never flips and it still gets a lot of spin. And in our prototyping data, we were able to shoot from like 25 feet really reliably. So that's why we went with this decision.
Sebastian, we got to talk about some of the programming on this robot here. Once again, I'm thinking going back to the OA show when we had you on, just such concise conversations we had to have on that. So I know you're using odometry, but you got some other really cool stuff as well too. So walk me through what you're doing.
Yeah, sure. So as you can see here, we've got 2 limelights here, and we're using the Dogekai Lib odometry estimator. So we're feeding all of these in to our internal odometry using both internal wheel odometry and the April tag odometry, and that really helps us dial in our shooting. We realized actually at comp that the tags at home definitely need to have a much higher, need to be weighed a lot less than they do at comp, just because we see the more tags here at comp than we do on the field. So just making sure we're tuning that and making sure that we can understand what's going on in the field is really what's going to be important to get us shooting. And then another thing that we wanted to address was one change that actually we made between Hartford was we switched to black stealth wheels for our flywheel. We used to have Fairlane wheels. And the reason why we switched was mainly because it caused a lot of vibration when at high speeds, so much so that our limelights here would actually just get too much oscillation and we wouldn't be able to see the tags when we're shooting, which isn't all that great. So by switching to these black black stealth wheels, we're really able to minimize that vibration, just because the moment of inertia is much more equalized than the regular wheels. Another change that we made was we switched to Krakens for shooting. We used to run Neos, but we had a really rough time getting that filter tuned in on the Neo themselves, and also on the actual Robo-Rio code. We were trying to use state space control, but that didn't pan out too well, so we switched to the Krakens, and they were much, in our opinion, much better performing for the high speeds that we needed, and to keep the vibration down. So it was a very necessary approach. One other thing that we've added, and according to the new comp, was the new LEDs right here. This is just to keep us informed about what's going on in the field. So these blue lights are static. When you run, can you actually enable real quick? When you run the intake, they will, yeah, you can just hit the intake button, run it. They'll run red, and then if we put a note in, they'll turn green to let us know that we're ready to shoot. so we can just go ahead and start running up and shooting. And this has been really, really helpful to get an understanding of what's going on in the field, especially because it's really, really in a tight space. And that's just something that we've been really improving on throughout this season.
Let's talk about localization in your robot. How
Yeah.
are you detecting different elements on the field, or just in order to get your robot localized? And with the odometry, how are you correcting for drift, that sort of thing?
Yeah, I really appreciate you asked that question. So for many of this, these limelights get added into what's known as like a filter. So this is using a common filter, and we base the we add the tags based off of how far away the distance is. There's a bit of some logic in between about whether if we see one tag, the distance that we accept into our odometry will be a lot smaller compared to seeing 2 tags or more tags. Basically, the rough estimate of is the more tags we see, the closer we are, we add them in, and we make the standard deviation between that and the internal wheel odometry much lower. And that allows us to really hone in on shooting. And this has been quite an issue we've had to really hone in. I know that a lot of teams are just using the front 2 April tags on the speaker, and we were thinking about that for a minute, but we decided against that, mainly because we wanted to be able to sort of shoot from, hopefully from wherever we wanted to be, wherever on the field, which wouldn't be great if we couldn't even see the tags from that far away. And another big benefit of these April tags, or these limelights right here, is that because they're attached to the elevator, we can actually raise the elevator and still shoot. So we can actually raise and just shoot right above defense, which is a really great addition, and also why having that odometry estimation is a great add. So yeah.
Well, Wired Boars, congratulations on a great season so far. Awesome robot. And for everything you do for the FRC community, showcasing your processes, I think it's phenomenal. So good luck here at Western New England, and we can't wait to see you throughout the rest of the season. Thanks a lot.
Thank you so much.
Support funds content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.